Introduction to computer architecture, difference between computer architecture and organizations, computer design, digital logic circuit and components, combinational logic circuits, half adder, full adder, 4-bit adder and subtractors, multiplexer and demultiplexer. What is the computer architecture? Computer architecture is a specifications describing how hardware and software technologies interact to create a computer platform or a system. A computer architecture is a specification detailing how a set of software and hardware technology standards interact to form a computer system or platform. In shortly, computer architecture refers to how computer system is designed and what technologies it is compatible with. And in short and sweet, we can say a computer architecture is basically the behavior that is observed by a user is known as a computer architecture. What is the difference between computer architecture and computer organization? Basically, computer organization is an arrangement of the computer component in such a way that we can perform the specific task in effective way. It means arrangement of the computer components is known as a computer architecture. So there are some basic difference between computer architecture and computer organization. So this difference is based on some key points. Now first difference based on the purpose. Computer architectures provides the functional behavior of a computer system, while the computer organization explains how a computer works. Next key point is target. In computer architecture provides the functional behavior of the computer system, and computer organization provides the structured relationship between parts of the computer system. Next point is design key. The computer architecture deal with high level designs, while in computer organization deal with low level design. Next key point is order. The computer architecture is designed first, and after that we design the computer organization. Or computer organization is started after finalizing the computer architecture. Now next term is computer design. So what is the computer design? Computer design is concerned with the hardware design of computer. Once the computer specializations are formulated, it is the task of the designer to develop the hardware for system. Computer design is concerned with determination of what hardware should be used and how the parts should be connected. So this aspect of the computer hardware is sometimes referred to the computer implementation. Next point is, what is the digital logic circuit? The digital logic circuits are basically building block of a digital system. The digital logic circuits are physical building blocks of integrated circuit, it means ICs, used for the execution of logical operations or tasks by utilizing the Boolean logics. The digital logic circuits can be classified in two categories. First one is known as a combinational logic circuit, and second one is known as a sequential circuit. Basically, these combinational circuits consist of some logic gates. So there are classifications of the digital logic circuits. Digital logic circuit is divided on two categories. First one is known as a combinational logic circuit, and second one known as a sequential logic circuit. So what is the combinational logic circuit? The combinational logic circuits are memoryless digital logic circuits whose output at any instant in the time depend only on the combinations of its inputs. It means the output directly depends on the input. In the combinational logic circuits have no memory, timing or feedback loop with their design. So basically combinational logic circuits are memoryless and there is no any feedback loops. Now there are some list of the combinational logic circuit like half adder, full adder, 4-bit adder or subtractor, multiplexer and demultiplexer. First one we learns about the half adder. What is the half adder? Half adder is basically a combinational circuit which is consist of one AND gate and one OR gate. That is the logic diagram of the half adder. In this half adder, we basically use two input and get two outputs. One output is known as a sum and second output is considered like as a carry. This carry is forwarded to add the next column. Now, this gate basically denotes the XOR gate and output of this XOR gate is represent X XOR B because input is given here A and B. So, output of sum is denoted by X XOR B. If we expand this equation, then we can say that X bar B plus A bar B plus A B bar. So, that denote the output combinations of the binary inputs and carry is denoted by A and B. It means this AND gate is basically used to create the carry generated at the time of adding 2 bits. Now, we consider here that denote the two tables of half adder. If input binary values of A and B both are 0, then sum is 0 and carry is 0. If any or 1 is 1, then sum is 1 and carry is 0. If both inputs are 1, then sum is 0 and carry is 1. So, that truth table basically denote the functionings of a half adder. So, how would give the output the half adder that denote this truth table. Now, next adder is known as a full adder. Basically, in the full adder, we basically take 3 input and get 2 output. Here, A, B and C is considered like as a input and output is S denote the sum and C out denote the carry output. Now, this diagram denote the logical diagram of the full adder. Now, we consider how full adder do works. Now, basically full adders are used to add the 3 binary bits and these binary bits may have the value 0, 1. Number of the outputs also depend the number of the inputs. So, if there are 3 inputs, then he can provide the 8 output. This output is calculated according to by 2 power n and denote the number of input. Here basically we also know that the full adder is combination of 2 half adder and output of S is denoted by X XOR B, B XOR C in and output of the carry is denoted by A, B plus C in A XOR of B. So, using these expression we basically can design the truth table. Now, if input for A, B and C means all inputs are 0, then carry output is 0 and sum is 0. If A and B are 0 and C in is 1, then carry output 0 and sum is 1. If A is 0, B 1 and C 0, then we can say output carry 0 and sum is 1. So, in shortly we can say if two inputs are 0 and one input is 1, then carry out is 0 and sum is 1. Two outputs are 1 and one output is 0, then we can say that sum is 0 and carry is 1. There are two inputs are 0 and one input is 1, then output will 1 and carry is 0. If all inputs are 1 1, then created carry is 1, means C out is 1 and sum is 1. So, that two table denote the behavior of full adder, or in other words we can say that denote the functionings of a full adder. Now, other combinational circuit is adder and subtractor, 4-bit adder or 4-bit subtractor. This is a special design combinational circuit diagram in which sometimes it behave like as a adder and sometimes it behave like as a subtractor. So, due to this reason it is known adder subtractor. That depend on the user how much bits he want to create. It may be 4-bit, 2-bit or 6-bit full adder. So, overall operation is basically controlled by the K mode. K is denote the mode bit. It means if value of the mode bit is 0, then we can say that this overall combinational circuit will do work like as a adder. And if value of key K is 1, then this overall circuit will do work like as a subtractor. So, how do work it like as a adder and how do work it like as a subtractor? That overall depend on the mode value or K value of this circuit diagram. So, this K bit is also known as a mode bit. How do it like as a sum? If we denote give the input or key value 0, then this 0 will not affect the output of this XOR gate. So, due to this output of this XOR gate will be B and this output will go to the full adder and next input will given by the register A. So, there are two input. First output of this XOR gate, next the input of this register and third input is created carry, and in starting we take this created carry in like as a 1 0 for adder. So, because that is the diagram of the full adder, so it needs the 3 inputs. So, 2 inputs are given from this side and 1 input is given from the mode bit. Now, in the case of the 1, the output of this XOR gate is always complement of B, and in this complement we again add the ones. The complement of B plus 1 denote the negations of the B. So, due to this reason it is work like as a subtractor. So, that is the circuit diagram of adder and subtractor. Now, next combinational circuit or combinational logic circuit is known as a multiplexer. So, what is the multiplexer? Basically, multiplexer is an electronic device that works on the principle of many input and one output. In other words, we also can say that the multiplexer, which also commonly used as a MUX or MPX, refer to selecting one output of the many available inputs, and The definition of the multiplexer is also introduced by a professor, Shankar Balachand. He explains that multiplexer is a method of transmitting a large number of the information units over a small number of channel or lines. So, a digital multiplexer is the combinational logic circuit that selects binary information from one of many lines and direct it to a single line output. So, we can say that a multiplexer do work on the principle of many input or one output. Now, here we take a diagram of the multiplexer, that is the 4 cross 1 multiplexer, because their inputs are the 4 and output is 1. So, due to this reason it is known as a 4 cross 1 multiplexer. Basically, number of these inputs are controlled by the selecting line. So, number of the selecting line is also depends on the number of the input. If number of the inputs are 4, then we have to tax the 2 selecting line. If number of the inputs line are 8, then we have to tax the 3 selecting line. So, these selecting line is basically do role of managing these input line one by one. Now, here we make a truth table of these 4 cross 1 multiplexers. Here selecting line is denoted here S0 and S1. If we tax the value of this selecting line 0, 0, in this case he always select the D0 input line and drop all D1, D2 and D3 line. So, this D0 selecting line is denoted at the output terminal. If the value of S1 is 0 and S0 is 1, in this case we select the D1 input line and drop all other lines, and at the output terminal Y we get the input D1. Similarly, 1, 0 we activate the D2 input line and deactivate all remaining lines, and at the output terminal Y we obtain the D2. And similarly, when both inputs are 1, then we get the data line 3 at the output terminal Y. So, we can say that overall role is played by these selecting line, and these selecting lines values produce one by one output of the all input lines at the output terminal. Circuit is demultiplexer. Basically, this demultiplexers do works at just opposite of the multiplexers. As we know, a multiplexer is used to reduce the number of inputs into the one. It means many input and one output, and this demultiplexer just do opposite works of the multiplexer, in which in this we, if we take m inputs, then we have to produce the n output. So, a demultiplexer is a device that takes a single input line and routes it to one of several digital output lines. A demultiplexer of 2 power n outputs has n selecting line, which are used to set with output line to send the input. And in other words, we also can say that demultiplexer is also known as a data distributor, because it distributes a single line at the multiple output lines. So, it is just opposite of the multiplexer. In one input line can be distributed in the many output line. So, here we take the physical diagram of demultiplexers and its table. Here we take 1 cross 2 demultiplexer. It means one line is distributed at the 2 output terminals, and basically this Number of the output terminal is controlled by the selecting line. Now here we text the input for selecting line, and here our input line is only a single. D line denote the input line and S is a selection for getting the output or distributing this input D line at the output terminal Y0 and Y1. So we select one by one value of input and selecting line. If selecting line value is 0 and input line is 0, then output terminal we find y1 and y0 0 0. Now if selecting line is 0 and input of data line is 1, then at y1 terminal we receive 0 and y0 terminal we receive 1. Similarly, when selecting line is set by 1 and input line is set by 0, then at both terminals we find 0 0. And if both lines are 1 1, it means selecting line 1 and input line is 1, then we get the output 1 0. Y1 terminal we receive 1 and Y0 terminal we receive 0. So that is the basic principle of a demultiplexer, how a demultiplexer reflect one line to the multiple output lines. So that is the basic principle of a demultiplexer. So today our combinational circuit is finished here. In next lecture we will learn about the sequential circuits. Thank you.